All right, so part 3 of going over the second exam here. So we're on question number 14 is where we left off. It says a cup of coffee has a certain number of grams of caffeine, a volume of 0.350 liters. The molar mass of caffeine, I give you the formula. You don't really need it because I tell you what the molar mass is, just to help save you some time. What is the molarity? So, you know, the real key here is, right, molarity is moles per liter. I wanted you to know that, but I was nice and gave you what that is here too. So what do you want to do here? Well, you're not in moles, right? You need to get into moles. So you need to know how many moles. So basically you're going to have 1.03 times 10 to the negative 1 grams, okay, and divide that by the molar mass, right? Or the way that we commonly set it up is like this, right? 194.19 grams per 1 mole of caffeine, okay? And if you enter that into your calculator, you're gonna get 5.30 times 10 to the minus 4. And that's gonna be moles. And so molarity is just going to be that number of moles per liter. And we're already given the amount of liters, which is 0.350 liters. And so you enter that in the calculator and you get 0.0015 molar. That's not in scientific notation, but we know 1, 2, 3 to the right. That's the same as 1.5 times 10 to the minus 3rd molar. So that's our answer for that one. Next one here, question 15. An aerosol can contains 800 milliliters of compressed gas, okay? At a certain pressure, when the gas is sprayed into a large plastic bag, the bag inflates to a new volume. Right? What is the pressure of gas inside the plastic bag if the temperature did not change and all of the gas was completely transferred? Okay, so this is a gas changing type of problem. And so the formula, well, everything comes from PV equals nRT, but the formula that I give you, which is one step derived from PV equals nRT, is basically that P1 V1 equals P1 V1 divided by N1 T1 equals P2 V2 over N2 T2. Okay, well, it says the temperature did not change. So T1 and T2 are the same. So they're T1 equals T1, or P1 equals T2. And so both of them equal T1. So you can cancel them left and right. And the number of moles didn't change, right? Because it's a closed plastic bag. So those stay the same. So we're left with P1 V1 equals P2 V2. So now we just plug in. And I notice one thing, that I need to keep my units consistent. This is in liters and this is milliliters. So I'm going to convert the milliliters to liters. I know that there's 1,000 milliliters in a liter. So that's going to get me 0.8 liters. 800 liters equals 0.8 liters. And my pressure, P1 is known, it's 10.2 atmospheres. My volume, I just turned it into liters, is 0.8. And I'm solving for P2, don't know what that is, but I know my final volume is 4.14 liters. And so now I can go divide that out, multiply that, I get 1.97 atmospheres. Okay, that's P2, which is the first answer there. Okay, the total atmospheric pressure on Mars is 4.6 torr. What is the total atmospheric pressure in atmospheres? So Let's just do these next two. Okay, so this is just asking about conversion. And so on the sheet up in the beginning tells you that, torr, that there's 760 torr for every 1 atmosphere. Torr on top cancels with torr on bottom. So this is just a simple division problem, just testing your knowledge of how to convert. And you end up with 0.0061 atmospheres. Okay. And so that is that first one right there. Next one, atmosphere on Mars is mostly carbon dioxide, 95%. The remaining gases are these other percentages. What is the partial pressure of CO2 on Mars? Okay, so well, there's 95%. That's the same as saying 0.95. So I'm just going to do 0.95 times the total atmospheric pressure, which is given to me as 4.6 torr, right? And so 0.95 times 0.46 is going to be 4.37, okay, or 4.4 torr. So that's the other one here. All right, 4.4. Okay, so we'll see you in the next video.